Hello, grade 12s. We are going to finish off the 2.3 notes where we left off last time. So remember where we were introducing our TVM solver, which is a way that we can calculate different parts of an equation regarding some sort of financial calculation having to do with compound interest. This is different than simple interest, so this program is only available or only useful for compound interest questions. And very often we can tell what the question refers to compound interest because we will have a compounding period. So very often we will see the word compounds or compounded in the question, which could help clue us in that this would be something we can solve with the TVM solver. As we go through these questions, obviously, I'm going to do them with you. However, I would very much appreciate if you can actually try them before we do them together, or at least fill out anything that you can first, so that way you could see if you're on the right track. Everything that we do, you should also be plugging into the calculator on your own, because although it's great to have the actual values inputted properly, if we're not able to use the calculators to figure out what our final answer should be, then we're only getting one out of the two possible marks there. Okay, we left off with example 2, so that's where we're going to start right now. So Amy invests $4,200 in a GIC that compounds annually. If you remember from our first day, we talked about GICs. That stands for a Guaranteed Investment Certificate, which is essentially a loan that you give to the bank. The bank spends that money, invests it, does something with it. They collect interest, and then they give you a kickback. So just a quick reminder about GICs. But Amy invests $4,200 in a GIC that compounds annually. If her investment is worth $6,300 at the end of 10 years, what is the interest rate that the GIC offers? Okay, so I kind of circled things as we went along that are some key words that hopefully we're picking up on. As we talked about in class, usually I%, that interest rate is a percent, as well as the compounding per year are the two easiest things to plug in because their values do not depend on anything else and there's no positive or negative associated with them. But in this particular question, we are looking for that interest rate. We're looking for that I%. Our compounding is annually. As we know, compounding per year, the amount of times per year annually refers to is a 1. So we've kind of checked off a few of these. We only have 2 other pieces of information. One is how much she invests. This is our principal or our initial value, also known as our present value. Since she is investing that money, the sign in front of it is a negative. That money is leaving her wallet and going into an account. And we know how much she ends up with, right? That accumulated amount or that final total future value of that investment is $6,300. Now, at the end of an investment, she's getting that money back. It's something that she can get from the account and go back into her wallet. And because that money's coming back to her, it is a positive value. Now, in this question, we don't have any repeated payments, whether that's repeated investments or repeated withdrawals. So our PMT is 0, which by default then sets our payments per year as 1. And then we can either select end or beginning. It will not make a difference because if we have a payment of $0, it doesn't matter when we make it. It still has the same impact. And remember, to calculate N, we had payments per year times the number of years. And in this case, we know the payment per year is 1. We've already plugged that in. Our number of years in this question is 10. So the N value is 10. Now go ahead and plug that in. See what you get. Pause the video. Okay, welcome back, and hopefully you got 4.14%. Of course, we are rounding answers to 2 decimal places unless otherwise indicated. Okay, and that's it. That's all. That is our answer. Okay, so try example 3 on your own, or at least the first plug-in portion, and then we'll do it together. Okay, we are jumping into it. The bank offers an interest rate of 6.5%. This P.A stands for per annum. Remember when we were talking about interest at the beginning in our 2.1 section? We talked about some of the official language that's used when talking about interest rates. And oftentimes interest rates are based on a period of time. And that period of time is typically annually. Okay? Per annum is just a little bit of a fancy way to say that interest rate is based on an annual time period. So PA doesn't actually tell us anything new. It's just the official bank language associated with interest rates. Okay, so the bank offers an interest rate of 6.5% per annum, and it's compounded monthly. We now want to look at how many years it will take for an investment of $1,000 to be worth $1,200. Okay, try plugging things in. And welcome back. So, our first go-tos are I% and compounding per year. In this case, I% is 6.5. Compounded is monthly. Monthly occurs 12 times per year. That $1,000 is an investment. It is leaving her wallet and going into an account. And so that's going to be negative and is a PV. That's where she starts off with. And it ends up being worth $1,200 at the end. That value's plugged in as a positive value because it is returning to her. Now, it's really important in both this question and the other question that these two values have opposite signs. Because if we start off with a negative PV, that means money is leaving me. I'm giving money to the bank. But if in an investment I end up with a negative FV, that means I now still need to give money to the bank. I owe money, which isn't typical of something that we see, and will end up with some pretty funky values. We will very likely end up with a negative N value, or a negative in a spot that we aren't anticipating it to be, or it would cause a red flag if it were there. So that's just something that we need to be kind of weary of. Okay, again, there's no talk about repeated payments. So PMT is 0. By default, PY is 1. And we're just, again, selecting end if it doesn't say beginning. But, again, it wouldn't make a difference in this particular case. Now, this question is asking us about how many years it will take. Now, remember, N doesn't actually stand for the number of years. N stands for the number of payments. And we calculate N by saying the payments per year times the number of years. So whatever that value we end up getting, so we don't know what it is, I'm going to put a question mark for N. But technically, that N value is not always the same as the number of years. It can be, depending on what PY is, but it is not always going to be identical. So we are going to plug that in, and we should end up with an N value of 2.81. I've rounded it so far, but just hold off here. Okay. Now, something that I know is that, that N is equal to my payments per year times my number of years. And if I plug in the values that I know to this formula that we know is how to calculate N, 2.81 equals 1 times my number of years, I can guarantee or confirm that I end up with the correct value for the number of years. Now, in this case, when I do that math, I end up dividing both sides by 1. So I'm really not changing anything, which is why I didn't actually show all the decimals here. But there are situations that we're going to face moving forward where my PY is not always going to be 1, which means my N value and my number of years is not always going to match. Now, of course, we at the beginning of our unit are just starting off. We are beginners at using TVM. So we are starting off with all of the examples so far not having a single payment. So it makes sense right now that when we divide, we don't actually see that difference because my PY is 1. This is not something that will always be true and is something that we want to keep an eye out for moving forward. Okay. Another one. We've got Charlie. We are going to go through this example, but I'd, again, like you to try it yourself. I will just point out that when it says plus taxes down the road, let's assume 12% tax because that's what we have right now in Manitoba. Okay, pause, try it on your own. Okay, welcome back. Charlie is saving her money to buy herself a new princess dog bed. The bed she has her heart set on costs $1,300 plus that 12% tax that we assumed. She wants to buy the bed 6 months from now as a third birthday gift to herself. Her bank offers a 6% interest, compounded monthly investment to dogs looking to buy new dog beds. How much money does Charlie need to invest today to be able to purchase her bed? Okay, as we're going through here, there's a couple of pieces that stand out, right? That $1,300 plus taxes, that's what she needs. She wants to do this in 6 months from now. The interest rate is 6%. It's compounded monthly. And we want to know how much Charlie needs to invest today. So we are looking for the present value. We are not looking for the future value. We want to know at the beginning how much she needs to invest to then be able to end up with the correct amount of money. Okay. Now, when we take a look at this, that $1,300 plus taxes, that's something she's going to need down the road. That's something we're going to have to calculate. But let's start off with what we've always started off with. Let's start off with our I% and our compounding periods per year. Our I% was 6, so yay, done. Monthly, that's 12 times a year. So those two are typically the straightforward one we could pull out from here. Okay, now let's circle back to that $1,300 plus tax. Now I need to know how much Charlie actually needs. So the cost of the bed is $1,300 plus 12% tax. As we know and reminded of our design and measurement unit, that's just multiplying 1,300 by 1.12. And we get $1,456. Now that is how much she is going to need at the end of her investment, which means my future value, the amount that we get back from the bank at the end, needs to be $1,456 at that minimum, right? Obviously we could have more, but this is what we would need to end up with to purchase that dog bed. Now, of course, this value is positive because at the end of my investment, the money is coming back to Charlie and going into Charlie's dog wallet. Yes, Charlie is a dog. Okay. Now, in this case, I want to know how much she wants to invest or needs to invest. So I am looking for that PV. Now, just thinking about what my answer should look like, I am expecting that PV to be a negative number. Because if you are investing money or Charlie is investing money, then Charlie is having money leave her dog wallet and go into her dog bank account. Okay, that directionality is important. So if I don't get a PV that is negative, that's a little bit of a red flag, and I've probably made a mistake somewhere. Okay, so I want to look into that. Now, Charlie is not making any additional investments, right? She is not making any repeated deposits. So our PMT is 0, our PY by default is 1, and our PMT is end again or beginning, but end is kind of the default unless it states otherwise. Now, as a reminder, N is my PY value times the number of years. Now, I know PY is 1, but the number of years, well, I actually have it in months. I have 6 months. Now, I can do that conversion from months to years in my head, or I might just know that. how much of a year is 6 months? It's a half. So if I take 1 and times it by 0.5 or times it by 1/2, that end value actually ends up being a half. Okay, now plug this in. Again, we are expecting a PV to be negative. Now, the PV represents how much money she needs to invest at the very beginning, or right now, today, to be able to purchase this bed 6 months from now. So the directionality will exist with the negative, but it's also money, so I can round to 2 decimal places here. So I should get $1,413.00, but this is not where I express my answer. When we plug things into our TVM, I want to see what you get out. So I'm seeing this here, but that is not my final answer because my final answer needs units, and I am dropping the negative because, again, the negative only tells me information about the TVM and the directionality of the money, but it doesn't make sense in answering the question. So my final answer should be $1,413.07. Okay, moving on. Again, please pause, try the question, plug things in on your own, and then circle back once you're done. Welcome back. We've got Alessia. Alessia wants to buy a house in a few years. She currently has $12,000 saved up for a down payment. She figures in 3 years she will need at least $1,500. If she invests her money at 4.1% interest, compounded semi-annually, will she have enough? Okay, now this question is a little bit unique from the ones that we had before because it actually tells me a value that isn't necessary to plug in. Take a moment of all of the information that's given here, right? The 12,000, the 15,000, 4.1% interest, semi-annually, 3 years. When I'm looking at all of those details, one of them I am not using in TVM. Do we know which one? Okay. As we go through here, the one we are not going to be including in TVM is that 15,000. Why? Is because we are simply seeing if she will have enough money. We know she needs 15,000. That's what she needs. We want to calculate what she will have. Okay? What she has and what she needs are 2 different things. We want to see if those numbers align. So we are going to be calculating what she needs, or in this case, her future value of her investment, and then make a response based on that number. So if she ends up having less than $15,000, we'll say no, she does not have enough. Whereas if she has that much or more, we'll say yes, she did invest enough. Okay? So, going ahead, looking through here, I%, easiest one to do, followed by my compounding. Remember, semi means every half blank, so semi-annually means every half year, which means it'll occur 2 times a year, right? There are 2 half years in 1 full year, so CY is 2. As we go through here, she's investing 12,000. That is a negative value because it's leaving her wallet and going into this account. We are looking for the future value. Okay. PMT, there is no repeated payments. By default, PY would then be 1. PMT would be end. And then when I take a look at my N, of course, that is PY times my number of years, which is the same as 1 times 3, which gives me 3. Now, important pieces to also recognize of how did I know that this 1,500 wasn't going to go in there, other than the end part saying, will she have enough? Okay, if I plugged in every single value that I had here, I would actually have no blanks. And the whole idea of TVM Solver is that it is solving for a missing value, right? Which means every single time we do TVM, we will only have one unknown, We cannot have more, we cannot have less. Because if we had 0 unknowns, we wouldn't need to solve anything. And if we had more than 1 unknown, well, then we won't have enough information. Okay? So we will always have 1 unknown, which means if I plugged in everything and I'm like, hey, where does this question mark go? There's no spot for it. That's my reminder, that's my indicator that one of these values must not be part of it. And hopefully we can rule out that it's not the number of years, it's not the interest rate, it's not the compounding period, based on the end part of the question, the phrasing of it. Will she have enough? Will she have enough talks about her future. Will she eventually have that appropriate amount of money, that end game money? So we're looking at that future value. Okay, hopefully in the time of my talking, you've plugged that in. And we end up with a future value of a positive $13,553.74. Again, I'm rounding to 2 decimal places always for money. So I can go here, it's part of my final answer. But again, this question didn't ask me for how much she'll end up with. My question asked, will she have enough? So I'm going to write a statement. I'm going to write a really nice statement with the value that we got for a future value in there. So I'm going to write, since $13,553.74 is less than the $15,000 she needs, she will not have enough. Okay, now this is a follow-up of that question. So the question was still about Alessia. We're still asking about Alessia. Alessia's like, oh, darn, I don't have enough. But she decides to invest that same amount of money in a GIC, so a different account, that earns the same amount of interest, but the difference here is that it's compounded weekly. And the question is, will she have enough now? So notice that between the 2 questions here, there's actually not much that changes. Between the question at the top, the original example, and this question here, we have that same $12,000. We have that same interest rate. It doesn't explicitly say that in the part B of things that it's still the 3 years, but it doesn't say that it's different. So we're still maintaining that 3 years. The thing that's changing here is our compounding period. So before it was semi-annually, now it's weekly. Which means as I take a look at things, when I plug things in, I'm essentially plugging in the exact identical thing, except instead of a CY of 2, I'm taking a look at CY of 52, which tells me about my weekly. So I'm going to go ahead and just straight up copy everything down from above, just changing CY. Now, the great thing about changing only one of my values is I could talk about how that one value impacts an investment. So we'll finish things off. I plug this in. I get a future value of $13,569.96. I still want to answer the question. I'm going to do it in the exact same phrasing. Since $13,569.96 is less than the $15,000 she needs, she will not have enough. Now, as I'm copying things down to ensure the same phrasing, I realized I made a mistake. I thought I said out loud that she will not have enough, but I did not write the word not in the previous example. Shame on me. But hopefully you caught that, and hopefully you wrote it down. And if you didn't, it happens to the best of us. But please add that in now. She will not have enough money in either of these cases. But let's talk about the money that she has In both of these situations, where only the compounding period changes, right? When it compounded less a year, right? It only compounded twice. She had $13,553.74. But when I compounded more often, 52 times a year, we ended up with $13,569.96. What can we say about how compounding more frequently affects the amount of interest accumulated? Well, if we're taking a look at these values, of course, we did not calculate the actual interest, right? In this case, the interest that she calculated isn't $13,000 and change, right? That's just the difference between her original amount and that future value. But in this case, we're seeing that that original amount is staying the same for both examples. So the only reason that her end of her investment is higher must be because she's earning more interest. So when I take a look at this, I compound less, I earn less. I compound more, I earn more. The reason I can very directly compare the effects of compounding periods is because every single other line in that TVM solver is identical, which means I can rule out any impact the amount I invest has on it, the amount of payments I make, the interest rate, the number of years. I could rule all of that out because it's staying the same. Whereas the only thing changing is the compound periods, so the effect must be from the compounding periods. Okay, so to end things off here, to write that down, how does the compounding period affect the amount of interest accumulated? Well, the higher the compounding frequency, the higher the compounding frequency, the higher the amount of interest accumulated. On an investment. Okay, so the higher the compounding frequency, the higher the amount of interest accumulated on an investment. Which means if you are at a bank, you are trying to decide between two bank accounts and everything is identical. You're not planning to invest more in one than the other. You would do everything the same. The interest rates are the same. The length of time you're investing is the same. Everything's the same except the compounding periods are different. You are going to want to choose the investment with the higher compounding frequency, the one that compounds more often, because it'll help you end up with a little bit more money. Now, of course, we're not seeing massive differences, right? If we look back at those two examples, we were looking at, $53 to $69, right? So $16. But over time, you're going to see that gap get larger and larger. Like if I recalculated this, top and bottom, right? But instead of 3 years, I plugged in 30 years. I'm going to see a bigger difference between the additional amount of money Alessia would make if she chose the investment that compounded more frequently. Okay, final question. It's like a multiple choice question, so pretty cool. This is an example that's from a previous provincial exam, so I do want you to give it a try. So, using the following information to answer the questions and select the best answer. So you have two scenarios. Scenario one, you have a loan of $30,000 at an interest rate of 7% compounded monthly for 1 year. In scenario two, you have that same loan of $30,000 at the same interest rate of 7% compounded blank for 1 year. We notice that all of these are identical except we're going to have a different compounding period. We're filling in the blank. We are assuming there's no payments being made, right? There's nothing that will impact it otherwise. And we want to determine what compounding period frequency in scenario 2 would result in less interest than in scenario 1. Okay? So keep in mind what we just said before. Try and fill in the blanks. Give it your best shot. Okay, we're going through it. So in scenario 1, we were talking about monthly. We were talking about 12 times a year. In all of our options, every 2 weeks means every second week, aka bi-weekly. Since there's 52 weeks in a year, then every second week, which means there's going to be 26. There's half as many every second weeks. Daily, 365 days a year. Semi-annually means every half year, which means 2 times a year. And weekly, there's 52 weeks. Okay, now realistically, if the higher the compounding frequency will earn more interest, the reverse would be true. The lower the compounding periods or frequency, the lower the amount of interest. So I want the least amount of interest, which means I am choosing semi-annually. I'm choosing 2. But let's just talk about playing the game here. Because sometimes we get it, you're looking at a question, you have no idea where to start, and you're trying to make a best selection. Now, when I take a look at all these numbers, especially now that I've written them out, I can see I'm comparing all these numbers to 12. 3 of these numbers are bigger than 12, and 1 of these numbers is smaller than 12, right? And when we take a look at it numerically wise, it kind of makes sense that if I'm looking for not a very specific amount of interest, it's just less, then I should choose the one answer that is unique from the rest, right? So if we're just playing the game here, we also should be kind of pointing out that semi-annually would be the one that stands out from this answer set. Okay, and that's it. That is 2.3. Great. Have yourself a wonderful day, and I will see you when I see you. Bye.